Hi all, this is Mr. Yeager for physics, and we are looking at predicting products, which is our last part of this unit. We've already gone over balancing and identifying types of reactions. So this is the last thing, and it's a little tough where we're trying to obviously predict what will be produced. And there's a set of rules with the kind of set of steps with this to figure it out in the simplest way possible. Again, this is the This was created by another teacher in my chemistry content group. Again, I really appreciate everything she's doing. And here we go. So we're just going to jump straight into it because that's the way to kind of get through it. All right. So what we do is we look at this. We look at what we have, okay, to figure out what's happening because we need to figure out the type of reaction first. That is really the first step, is figuring out the type of reaction. Okay. We want to figure out, is this a synthesis, is this a decomposition, is this a single replacement, double replacement, or combustion? That helps us figure out what the elements are going to do on the product side. So we have to figure out the type of reaction. The way I do that is I kind of set up and I think about all those patterns in each of the reactions. I only have one compound to start with. It's AB, and so the only thing that this makes me think of is decomposition. And in decomposition, AB produces A plus B. Okay? And so we would go with this and we go, okay, it's going to split up into H and O. Now the thing is, this is where the diatomics come into play. And we need to know our 7 diatomics. When we split them up, or get a lone element, we have to determine, is that one of my 7 diatomics? Hydrogen is, so hydrogen will become H2. Oxygen is, so oxygen will become O2. That's how I can figure out my 2 products. So this would be A plus B. So we have to figure out the type of reaction. We then move the elements over based on type. Okay? Sub-rule to that would be, are they diatomic? And then the last step is basically all we're going to do is balance. So those are your 3 steps. So if I balance this one, I have 2 H's on the left, 2 H's on the right. 1 O on the left, 2 on the right. So I need to come back and put a 2. I now have 4 H's, so I need to put not 4, what am I doing? A 2. And there you go. 2, 2, 1 would be your balanced reaction. Okay? One more together and then see how you do with it. So this one's HGO. This is another decomposition. How do I know? The compound's all by itself. It has to split into its parts. So it's becoming Hg and O. Then I go, is it diatomic? Hg is a metal. No metals are diatomic. So that one's going to stay as it is. Oxygen, though, is a diatomic. It's one of my 7 diatomics. Then I balance. 1 Hg on the left, 1 on the right, 1 O on the left, 2 on the right. I need to bring back and put a 2 here. Now I have 2 Hgs, 2 Hgs. Okay? All right. So you try this one. All right. Pause for a second and try it out on your own. Okay? If you didn't pause, here we go. I would identify this as a decomposition again. Whoops, sorry. This would be a decomposition. AB, so it become K plus S. K is not a diatomic, S is not a diatomic, so they like to stay that way. So I have 2 Ks on the left, 2 Ks on the right, 1 S on the left, 1 S on the right. So there we go. Try one more decomposition. You can see we're going to kind of be doing them in type order. So pause. All right, coming back. If you didn't pause, here we go. This would be Ca plus Cl. This is again decomposition, A plus B. Ca is not going to be diatomic. It's a metal. Chlorine is. It's one of the halogens. All the halogens are basically diatomic. This one's already balanced if you do it that way. Good job. Okay? If you want to do pause. Okay? This should be, I'll keep doing that. It should be Cr plus P. Neither one is diatomic, so I just have to basically bring the subscripts over. Balanced. All right. Okay, synthesis. We'll do one together. Synthesis. I know it's synthesis because it's going to be A plus B. They're two lone elements. They're going to come together to form AB. So for this, I bring them together, KCl. This does add a step under that bringing the elements over. So bring the elements over, okay? Based on type, is it diatomic? If you're creating compounds, you have to balance the charges. You have to balance the charges, okay? The only ones you're probably not going to have to balance is carbon dioxide and water when we get to combustion. But we do need to actually check the formula. This is +1, this is -1. That means it's balanced, and this one's correct. So now I need to balance the overall reaction. 1K, 1K, 2Cl, 1Cl. Need to put a 2. Now I have 2Ks, 2Ks. Okay? NaO2. Again, synthesis. It's going to form AB, so I'm going to put NaO together. But now, because I'm creating a compound, I need to get the charges correct. So +1, -2. Crisscross. Na2O is the correct formula for sodium oxide. Then I can balance. 1 Na, 2 Na. Put a 2. 2 O's, 1 O. I need to put a 2 back over here on the right-hand side. Now I have 4 NAs, 4 NAs. Pause and see, figure out this one. Ooh, let me do something here. Sorry, no, don't pause. I'd have to give you the charge of this. Okay, so if I said this is +3. With transition metals, we will give you the charges if they are coming together to form a single compound. Okay? There would be no way for you to figure that out without us helping you with it. So, now pause. Okay? If you figured this out, I'm bringing it over. PTBR. I just said PT is +3, BR is -1, so this will be PTBR3. 1 PT, 1 PT, 2 BR, 3 BR. 2 and 3 raised to 6. So 3 times 2 is 6. I need to put a 2 there, so the 2 times 3 is 6. So I have 2 PTs now. Okay. Same thing with this one. I'd have to give you the charge. Okay. +4. All right. Becoming a single compound, SNS. If this is +4 and this is -2, I could crisscross, but I'm going to have to reduce. It would be 2, 4, so 1, 2. And then I can do balancing with just the 2 S's there. Okay? This is basically what you're doing with all of them. Okay, I'm going to skip those for a second, come back to it. Oh, never mind. So, now we have a double replacement. On a double replacement, AX, BY. Again, we move the entire polyatomic over. When we bring things over, I guess this hasn't really come up yet, we do not bring subscripts with us. We do not bring subscripts that tell us the number. We do bring the subscript for a polyatomic, but we're not going to bring the 2 there. Okay? So, if I'm doing a double replacement, this would be AY plus BX. And so I'm going to bring over A is PB, Y is S, B is K, and X is NO3. I'd have to do the charges on these. So you can see this can be pretty tough. It's going to be bringing in stuff from the prior unit quite a bit. All right? So this is tough. The charges won't change. So I'd actually have to figure out the charge of PB by using the NO3. If this is -1 and I have 2 of them, the overall charge is 0. X will equal -2 or +2. So this is lead 2. So this is +2, S is -2. They cancel each other out. K is +1, NO3 is -1. They cancel each other out. So now I can balance the whole thing. Okay? It's a bit, but all I'm doing is just regular compound forming with the charges and stuff. It's all a lot of ionic. I have 1 PB, 1 PB. I have 2 NO3s like we learned in balancing. So I need to put a 2 out here. I then have 2 Ks, 2 Ks, 1 S, 1 S, and that's it. It's balanced. Okay, let's do another one here. This would be AX, BY, AY plus BX. This would be H, don't bring the 2 with us, Cl, don't bring the 2 with us, plus Ba. We do bring for the polyatomic though, SO4. No transition metals, so I should just be able to look on the periodic table. Plus 1, minus 1, plus 2, minus 2. That's nice. I have 2 H's, 2 H's, 1 SO4, 1 SO4, 1 Ba, 1 Ba, 2 Cl's, 2 Cl's. So that's how we're kind of looking at double replacements. Okay? I'll do one of these and then another one, and we should hopefully, and then look at combustion, and we'll basically get it. This right here is a single replacement. So we're gonna, now, we do need to pay attention to what I got here. I have a metal, it's gonna replace the other metal. So this is gonna form AX plus B. So this will be AlCl plus zinc. Okay? I need to do the charges of these, plus 3 minus 1, crisscross, AlCl3, zinc, not a diatomic. So we're good there. Let's balance this out. 1 Al, 1 Al, 1 Zn, 1 Zn, 2 Cl's, 3. I need to raise to 6. 2 times 3 is 6. 3 times 2 is 6. That does give me 2 Al, so I need to put 2 there. It also gives me 3 Zns. Put a 3 there. Okay? All right, let me go back to combustion because I do have kind of a little method for combustion. Okay? So, first off, you see a hydrocarbon and an oxygen. This is the easiest to predict. It's CO2 plus H2O. Actually, we've already gone over, I'm thinking about that. We've already gone over that with the ways to balance combustions, with a little trick with doubling it if you need to. And always balance oxygen at the end. So, I mean, I guess there's not a lot to do. These should be easy to predict because it's always those 2 products. You don't have to do any charges. We just got to be able to balance. So 1C, 1C, 4 H's, 2, put 2 there. Add up the oxygens on the product side. 2 plus 2 is 4. 2 there. 2 times 2 is 4. Okay? C4H10 plus O2 forms CO2 plus H2O. Okay? So C4, I have 4 right there. I have 10 H's. I'm going to put 5 right here. I have now 8 plus 5 equals 13 O's. Oh, here's my trick. I can't get 13. So what do? I go back and put a 2 in front of the hydrocarbon, and I rebalance. Now I have 8 carbons on both sides. I have 20, 10 times 2, hydrogens. And now I have 16 plus 10 O's for 26 oxygens. 26 divided by 2 is 13. Okay? So, moving it along, obviously you could slow that down, go back and look over it a little bit more slowly if needed, or go through specific examples. But the main thing is identify the type of reaction, move the elements over based on that type of reaction. If it's lone elements, determine if it's a diatomic. If not, keep it alone. If it's a compound that you created, you've got to balance the charges. You've got to balance the charges. And then if you get a combustion, it's always carbon dioxide and water, and balance appropriately. All right, that's it. Good luck. You'll do great.